We're going to finish out this section on volume with calculus, looking at things in 3 dimensions, but this time we're going to be doing something called working with cross sections. Just a quick review of some geometry stuff. We want to look at these shapes here out in front of you, but we want to consider how to find the area of each of them when all we're given is the base. So for a square, that's pretty straightforward. Let's just say the base was b, then the height is also b, and the area is b squared. As we get into these other pieces, that's going to be changing a little bit. So if we say that the equilateral triangle, for example here, if the whole base is b, then half the base is b over 2. And thinking of this as like a 30, 60, 90 triangle, in which the relationships tend to be x, x root 3, and 2x, or it doesn't really matter what letter you use, but that height there is root 3 times whatever this short side's going to be. So this is going to be b over 2 times root 3 for this height. So then the area is going to be the base, the area of a triangle is half the base times the height, which in this case would be b times half the base times the height, which is b over 2 times square root 3. Now if I were to simplify all that, the area comes out to be square root of 3 over 4 times b squared. What you're going to find in each of these shapes is that you have b squared, or that base squared, times some type of constant. Just got to figure out what that is. So again, thinking about the whole base, in this case the whole base, it would be b, but just the radius, which helps us find the area of a circle, is b over 2. Keep in mind that this is a semicircle, half of a circle. So the area would be half pi r squared, and r in this case is b over 2. So doing some simplification there, area equals pi times b over 2 quantity squared. Then if I were to figure out what that constant is, it's going to be pi over 4 times b squared. Whenever you see a right isosceles triangle as being your cross section, that means it's a 45, 45, 90 triangle. And most often you'll have it with the hypotenuse as the base, kind of creating this pyramid looking shape. That tells me that if this is my base, then what I really need to figure out is my height, because if I know the height and the base of a triangle, then that helps me find the area. So the area equals 1/2 base times the height. But I need to figure out what this height is in terms of the base. Well, if I split it down the middle, that creates two adjacent 45, 45 triangles. And that would make each of these sides b over 2, b over 2, and the height also b over 2. So this would simplify to 1/2 b times b over 2, or even more simply, the area equals 1/4 b squared. So that constant was just 1/4. Sometimes you'll have a rectangle as well, where the height and the base are related by some type of constant. So let's say here's our base and here's our height, but the height equals some constant times base. Whether it's a fraction or an integer greater than 1, a whole number greater than 1, it doesn't really matter, but there's some type of relationship. Well, we know that the area equals the base times the height. But if the height or the base is multiplied by a constant, then it's really just that constant times the base times the base. Because that height can be replaced with a constant. So that constant winds up being the constant that we're looking for anyway. So the area equals the constant times base squared. Keep this in mind as we go through each of these shapes today. We're going to derive them again as we go, but this is going to help us as we work our way through just this type of thinking. Okay, we have a solid whose base, that word came up again, is bounded by the circle x squared plus y squared equals 25. We want to take cross sections, so we're thinking cross sections that are perpendicular here to the x-axis of squares. Well, if this is a base of a square, then what I need to do is find the integral from a to b of my area of my shape. Now before we did this with discs, where the area of a disc was pi r squared. But in this case, we're looking at just other types of shapes as well. So if I'm looking for a base here, trying to figure out what that is, I also need to consider what my shape is, which is squares. So I'm looking for the base squared. And my limits of integration, well, if I'm perpendicular here, that means my direction of travel is in the x, which is what I had written here before. So my x starting point is going to be -5. My x ending point is going to be 5. I just need to define what that base is then. Well, if I try to find the distance between two curves, that's just the top one minus the bottom one. Then I need to define what is this top curve and what is this bottom curve. Both of them are defined by the circle. And notice that in the red here, we're going to have the top half of it, and the green is the bottom half. So let's start with the red. The top is going to be this equation, but solved for y. So if I have y equals radical 25 minus x squared, that would be this equation, but just solved for y. The bottom, if we get a green color here, the bottom is y equals, that's kind of bright, let's do something a little bit darker. Y equals the negative square root 25 minus x squared. So here's negative square root 25 minus x squared, and on top was the other one, square root 25 minus x squared. So our base is just top minus bottom. The base is equal to that red one, 25 minus x squared, minus the green one, which is negative 25 minus x squared. Both of these in radicals. And since we have two negatives there, we can add them. If you have two of the same thing, that's really just saying 2 times radical 25 minus x squared. So that's our base. So if I wanted to find the volume is equal to the integral from -5 to 5 of 2 times the radical 25 minus x squared, which is my base, squared, because it's my base squared. Why is it squared? Because it's a square, and I know that the area of a square is just the base times the base. Let's try one, but slightly different here. If we're looking at equilateral triangles, remember, if we're looking at equilateral triangles, we have a shape that's kind of like this. And we need to know the base and the height. The base is just b. Each of these halves is b over 2. And this height is the radical 3 times b over 2. And when we put all that together, we had gotten the area equals 1/2 base times height. Well, the base is just b, but the height is radical 3 over 2 times b. So then this came out to be radical 3 over 4 times b squared. But hey, we already know what b is. We know what that base is. So the only difference between the last problem and this one is this constant. So I just have to do the integral from -5 to 5. And we have a constant, square root 3 over 4, times that base, which is 2 radical 25 minus x squared dx out here, and squared up there because it's the base squared. How easy is that? Let's do another one, a lot like it. Semicircles. So if I'm looking at semicircles, I'm just looking at the top half of the circle. I don't really care about the bottom half. So this top half up here, let's see if we can get back to a pencil. We're looking at this piece here. The area of that is going to be 1/2 pi r squared. But remember, r is really half of our base if we're looking at this as a semicircle sitting up on top. So then the base, r equals the base divided by 2. So then the area is equal to pi times b over 2 quantity squared, which simplifies to, if we square both the top and the bottom, we're going to get b squared, and the bottom is going to be 4. So let's have pi over 4. So there's my constant. So again, I'm going from -5 to 5. My constant's pi over 4. And I'm looking for 2 radical 25 minus x squared, all quantity squared, dx. There's my volume. So let's look at what it would look like with isosceles right triangle. Quick reminder, with this type of triangle, that means that we're looking at something kind of like this. And what we did is we said, here's our base, but we're going to split it so that we can figure out the height. Well, that makes 2 isosceles right triangles here. It means this is b over 2, and so is this. And hey, so is this. The height is b over 2. So normally the area of a triangle equals 1/2 base times height. And in this case, our base is the same. It's just b. But the height is b over 2. That means that if I were to try to figure out what this would be, we'd have b squared, like we've had with the other ones, but it'd be 1/4 for a constant. So when I set this one up, we're going from -5 to 5. We still have the dx. We still have our base squared, which is 2 radical 25 minus the x squared. And then out front, we have our constant 1/4. That's what we're looking for. See if we have any more.